Good morning, one all present here. My name is K. Muhammad Awais. I am from second year mechanical engineering. I want to today discuss about the numerical methods and transform techniques about one question about these related in the Nm&Tt methods. Today I am discussing about the convention theorem of the Laplace transforms. State and prove the convention theorem of Laplace transforms. Convention theorem useful to obtain the inverse Laplace transform to product of two transforms and solving the arbitrary differential equations. Definition of the Laplace of convention theorem. Let f of t and g of t is greater than 0 by conventional theorem. F of t into g of t equals to integral of 0 to t f star u g into t minus u du, where f star t is called convention product of and f of t and g of t is called the conventional product of an theorem of a Laplace transform. The properties of the convention theorem of the Laplace transform. Convention products of the commutative, therefore f of t star g of t equals to g of t in star f of t. Convention products is associated, therefore f of t star g of t star g of h of t equals to in brackets of f of t into g of t into h of t. F of t into g of t into 0 equals to 0 into f of t equals to 0. The theorem states that if L closed bracket f of t equals to f dash s and the L closed bracket g of t equals to g dash of s, then the Laplace transform of the equation it will be inverse to the L closed bracket f of t into g of t equals to f dash f of s and g of s, g dash of s. In next step it will be inverse to the, we are applying in L inverse f of s into g of s, it will be equals to f of t into g of t. Let die equals to t equals to f of t into g of t. Let phi t equals to log 0 to infinity e minus st phi t dt. After we are applying in the place of phi t, we are applying ft into g of t in the place of phi t. Integral 0 to phi e minus st is in a formula f of t into g of t dt. Integral 0 to infinity e of minus st in the closed bracket, we are applying limits 0 to t f of u g t minus u du dt. It is from the above in the definition of the Laplace transform of integral 0 to t f of u g t minus u du dt. From the above equation, we are taking the one side all integrals 0 to infinity integral 0 to t e minus st f of u g t minus u du dt. The above integrals is considered with the region of enclosed region of u equals to 0 and u equals to t. Integral u integral u to infinity e minus st e minus su e minus sv f of u g t minus u du dt. Integral 0 to infinity e minus st f of u du. We are separating the two transforms by the integrals separating two boundary conditions. Integral u infinity e minus t minus uv g t minus u dt. Here t minus u equals to v. If t equals to v, then v equals to 0. If t infinite, then v equals to infinite. Therefore, integral 0 to infinity e minus su fu du. Therefore, integral 0 to infinity e minus sv gv du. Here we have seen in the last page by the theorem of the next we have to state and prove this integral by adding this of L close bracket phi to t equals to f dash of s g dash of s L infinite f of t into g of t equals to f dash of s g dash of s and L inverse close bracket f of s f dash of s g dash of s equals to f dash of t into g dash of g dash t. We have proved that convention law of theorem, law of the theorem. Thank you. Have a nice day.